that we're covering today is called substitution method. So the method you guys did in your last lesson where you graph a system, that means two equations on the same coordinate plane, that's called the graphing method. So you were finding where the two lines intersect, if they did, and if they didn't, you said it was no solution. So now this is just a different method of finding the exact same answer. So notice on the title right here, you see where it says 1, 6. So if we were to graph this problem using the graphing method, we will get the answer 1, 6. So today we're not going to be graphing to get 1, 6. We're going to do it all by hand. So it'll be done all mathematically. Now, what is the advantage of doing the graphing method versus the substitution method? On the graphing method, you can only really read integers, like whole numbers and stuff like that. With substitution, you can end up with a coordinate that looks like 1/2 and 3/4. If you were graphing, you could not read this from a graph, because you might say, well, it looks like 1/2 to me, and somebody else might say, well, it looks like 1/3 to me. So with the substitution method, you can get exact answers. That's my point. You can get exact answers, whether they're fractions or integers. You will get the exact location where the two lines intersect. Okay, you can't do that with the graphing method, because if they don't intersect right with those integers, you can't read halves and thirds and fourths and fifths and everything else from a graph. So we're going to follow these steps. There are 3 steps, well, actually 4. The last step is just the answer. But the very first step is very important. You might want to put a star there. Sometimes that first step is done for you, where you have to isolate one of the variables, and sometimes that step is not done. Sometimes it's done, sometimes it's not. So looking at question number 1, I already noticed, because the first step says to isolate one of the variables. So notice this has been isolated for y. So that's already done for us. That's step 1, where you isolate one of the variables. So step 1 is done. So that means I can move on to step 2. So if you look at your title, the steps for step 2 says you're going to substitute that into the other equation. And that's why it's called substitution. You're going to be doing a couple of substitutions. Okay. Now, another word for equal in words is. Okay, is means equals. So this is really saying y is now negative 8x plus 20. Okay, that's how I would read it to myself. Like y is now called negative 8x plus 20. So where I see x in the other equation, because that's how it's written in the steps, it says replace that into the other equation. So this is my other equation. I'm just identifying that. So where I see x, sorry, this should be y. Where I see y, not x, because the y was the one that was isolated. So where I see y, I am going to substitute it with, and I'll put the substitution in red, negative 8x plus 20. There's the first substitution right there. So I didn't say 3x minus y. I replaced the y with the negative 8x plus 20. And that's step 1 and step 2. Step 2, finish just solving, because everyone knows how to solve an equation, so we just go ahead and solve it. 3x plus 8x, because a negative times a negative. And be very careful with this one. A negative times a positive is a negative 20 equals to 2. So I'll combine my x's together. I get 11x. Add 20. 11x equals to 22. And so I have my first coordinate, which is 2 for x. All right. So step 3, and I'm going to label these like this was step 1 here. This is step 2. So step 3 says to take your answer that you just got here. Here's my answer. And now you're going to substitute it back into step 1. So here's my step 1. Remember, this was my step 1 where the variable was already isolated. So now I am going to replace x with 2 because I just found x to be 2. Okay, I just found that answer out. So I'm going to substitute that back into my very first step. So that will give me y equals negative 16 plus 20. So what is the value of y? 4. And then the very last step is just to write your final answer as a coordinate. So yes, if we were to graph this, they happen to come out to be nice whole numbers. They would intersect at 2, 4. Okay. So to do a check, and you want to put this somewhere, and I'm going to put to check. It's always nice to know how to check your answers. All right. So what you would do is take both of your equations, y equals to negative 8x plus 20. And what was the other one? 3x minus y equals 2. All right, so to check my work, what I would do is replace my answers that I got for x and y into the problem. So my y value was 4, so where I see y, I'm going to put 4. My x value was 2. Okay, so this is negative 16 plus 20. So it checks out to equal to 4. And then you got to test it in the other one. You can't just test it into one. Sometimes it will work in the first one and not the second one if your answer is wrong. So you got to be very careful both. All right, so I'm going to replace x with 2. And 6 minus 4, okay, is 2. So 2 equals to 2. So you should end up with the same number on both sides once you're done. Okay, so that's how you do a check. I would definitely use this, for any assessments, just to make sure that your answer is correct. All right, let's move on to number 2. All right, so in number 2, step 1 is not done for us because, the x or y is not isolated. So we have to isolate either x or y. Now, a good rule of thumb, doesn't matter, no, but a good rule of thumb is try to look for coefficients of 1, like that's a 1 and that's a negative 1, because then you're not dealing with a lot of fractions. Okay, so try to look for coefficients of 1. So I have a choice. I could either do the x or the y. So I'm just going to choose to solve for x. You can definitely choose to solve for y. You get the same answer. Okay, so that means I just need to move the y over by adding it to the other side. That's step 1, is to isolate one of the variables. Okay, so I've done step 1. Step 2, and I'm going to put a 1 here because I always come back to step 1 to get my, in this case, it's going to be the x coordinate. So I have to come back to that once I find out what y equals to, all right? So now where I see x here, I am going to substitute it with y plus 2. Okay, so I'm going to put the substitution in green. All right. And then write down the rest of the problem. So I just did the first substitution. I found x to be y plus 2. I substituted that into the other equation. And now it's just a matter of solving the equation. So negative 2y minus 4 plus 4y equals negative 10. So 2y minus 4 equals negative 10. Add 4. 2y equals negative 6, y equals negative 3. Okay. So remember I said once I find out the value of y, I'm going to go back to step 1 to get the value of x. So do my other substitution. So here, this was step 2. So step 3, I'm going to write down what I got in step 1 and replace y with negative 3. All right, and there's my x value. Now I'm going to write it as a coordinate. So these lines would intersect at -1, -3. Okay. And I'm not going to ask that you check every single one, but I did show you how to do a check. In case you're doing a test or quiz, you can verify your answers. Okay. All right, let's move on. Number 3. Okay, number 3, there's only one variable that has a coefficient of 1. And I will show you later what happens if none of them, has a coefficient of 1. Okay, we're gonna talk about that, but not today. Okay, today we'll end up having most of them having a coefficient of 1, so it'll be pretty basic. So I'm going to solve this one for x. So I'm going to move the negative 3y to the other side, which means I have to add it over. So that'll give me 3y plus 22. All right, so this is my step 1. Okay, so now I'm going to substitute that value for x, or that expression for x, into the other equation. So I'm going to have 8, and then in parentheses, I'm going to write 3y plus 22. There's my substitution. Plus the 7y equals to -10. So I'm going to let you finish this out. Okay, so I want you to solve it for y, and then go back up here and get your value for x. Okay, so we ended up with 4 for x, and y is -6. So you do have to write this final step, guys, as a coordinate. Don't just leave your answers like this. Okay, don't leave them as y is -6 and x is 4. You actually have to have it written in parentheses since it is a coordinate. Okay. All right, so I'm going to let you all do the very last one, but this is something I want to point out up here, and you might want to write this somewhere. So what if, mathematically, what does it look like if you have no solution? So remember how we solve equations and we get two numbers that do not equal to one another, and we write no solution? That's what it's going to look like when you solve it. So if you end up with two numbers that didn't have a, right, if you ended up with that, then that's no solution. If you ended up with two numbers that are the same, that are equal to each other, that means it's the same line graphed on top of one another. So that means it's infinitely many because they're intersecting everywhere. So same thing here, infinitely many. This is what it looks like mathematically. Okay, this is what it looks like graphically. It just looks like one line. No solution graphically, you already know that was question number 2 on page 1, are parallel lines if we were to graph it. But this is what it looks like in number form, okay? Because we're not graphing now, we're using all numbers. So this is what it will look like. So you just want to keep that in mind. The second foldable deals with, or part 2 of the lesson, is going to deal with just setting up the word problems, but we're not going to solve them today, because once we learn the third method, then we'll go back and solve them, because the substitution method is not the best method to solve these. So we're only going to just set them up. Okay, so no solving. Same thing for homework. You'll see up there where it says do not solve. You're just going to set them up. Okay, so when you set them up, you're going to be using the standard form. Remember, ax plus by equals c is standard form. So this is how you're going to set up your word problems. And you have to follow directions. I know some of you are still working on that. So we have to follow directions, and where it says to define your variable, this is what it means. Like, say S will represent the student tickets, A will represent the adult tickets. And this is all I want to see today. This, how you define your variables, like what your variables will represent, and then what your two equations are. So that's what you're going to do, and then stop. We'll solve them later. Okay. Now, let's just say you always want to use X and Y. You don't want to use S for student. You can definitely say, okay, I'm going to have X to say student and Y to say adult tickets. You can use that consistently all the time. A lot of times on your, especially like your SOL test, you will see them use like the first letter of the label that's in the problem versus just X and Y. Okay. All right. So I'm going to have you all read this word problem to yourselves, and then we'll figure out how we're going to define our variables and how we're going to write our two equations. So go ahead and read it to yourselves. Okay, quietly to yourselves. And it might be a good idea to kind of underline some important things. All right, so what two things in here are they talking about? They're talking about two different types of transportation. What are they? Vans and buses. Okay, so we have high school A and high school B. So let's first, since we're talking about vans and buses, let's define our variables, and we're going to define them this way. Let's say V will be the number of students that rode on the van, and B will represent the students on the bus. Okay, so I'm going to assign mine V's and B's. And again, if you wanted to use X and Y, that'll be totally up to you. Okay. So if I look at high school A, it looks like they had 3 vans and 6 buses and a total of 255 students. So I simply write 3V plus 6B equals to 255. Okay, for high school B, okay, it looks like we had 11 vans, 12 buses with a total of 575 students. So you're going to say 11V plus 12B equals to 575, and you'll stop. Okay, that's as far as I'm going to have you go for tonight. Now, like I said, when we learn the elimination method, we'll come back and do the solving. Okay, so you'll see those words at the top, do not solve. All right. All right, let's move on to here. Okay, go ahead and read that word problem to yourself. So what are the two types of tickets? All right, so we have the senior citizen tickets and the child tickets. So I'm going to name them S and C. Okay, price of the senior citizen ticket or the senior ticket and price of the child ticket. All right, so let's see if we can write the first equation. It looks like we have 9 senior citizen tickets and 9 child tickets, and the total was 171. So of course that'll be 9S plus 9C equals $171. And then we have 3 senior tickets and 7 child tickets, which equals to $109. So we say 3S plus 7C equals to 109. Okay. So please make sure you have how you represent or what your variables represent. And then all you have to do is then translate into your equation. Okay. All right, so I'm gonna let you do this one. I'm gonna at least let's so everybody will have the same definition. So it looks like we're talking about hostas and ornamental grass. You guys know what hostas are?
Yeah.
Okay. How many people have seen a hosta before? All right, I have a picture. This is a hosta. Okay. These are all right. They come in several varieties. Very pretty colors. They're considered perennials. What are perennials? They come back every year. So basically, you cut them down all the way, like to the bottom in the winter, and then when the spring comes, they come back like double the size most of the time. And every year they just get bigger and bigger and bigger and bigger.